Good morning. Thank you for listening. So there are more than 30 questions in this review document. I will post it and I will also post a solution key. I'm going to touch base some of them. So this is not limited. Please don't misunderstand that your test will be limited only these questions. They are good examples, and make sure that look at all the questions and the solution key and listen some parts of this recording. So some example questions I will solve. This is part one. So first of all, we're solving an equation, question one. So this is variables on both sides. We need to get rid of parentheses. They're always headache. Be careful when you're distributing the parentheses. For instance, this case, in both cases, we have negatives that we need to distribute. Okay, so that will be 8 minus 4x plus 12 equals negative 40 minus 16x. So we have variables on both sides. We need to collect variables on one side and the constants on one side. So I'm going to have negative 4x here and plus 20. Still, first do the simplification, then move the variables, if you will. Moving the variables meaning add 16x, subtract 20 at the same time. Then we're going to have 12x here, right? And that will be negative 60, and x will be equal to negative 5, and we are done. So there is like a metric of your comfort here. Make sure as you go along the way, when you're checking the solution key, rate your understanding and comfort level. Okay, so the next question is about solving an inequality with the same principle. We need to get rid of the parentheses. Okay, so then this line will be negative 2x plus 12 plus 24x minus 30 plus x. So the only difference is instead of equation, we have an inequality sign. Same principle, combine like terms, get the variables on one side and the constant on one side. So I'm going to combine like terms here. That will be 22x plus 12 minus 30 plus x. So that will be negative x, negative 12, negative 12. And then we're going to have 21x less than negative 42. So we divide both sides with 21. Right, hence we're dividing both sides with a positive number, so there is no sign change. If we were dividing with negative 21, had we had negative 21, we needed to make a sign change. So that is an important aspect. Then we're going to have x's less than negative 2. So this is an inequality form. We will always ask you to write it in an interval form. If you think about it on a number line, 0, negative 2, negative 2 is like that, and the solution lies here. So that area shows negative infinity, always in parentheses. Infinities are always in parentheses. It's a parentheses for negative 2 because we're not including negative 2. Okay, so now let's solve an equation, but this time this is a second degree equation. And the way it's been asked is use factoring. So when you're solving a second degree equation or a third degree equation, solving an equation though, like make one side of the equation 0 and factor and find the zeros. So then I will subtract negative 3x, negative 4, negative 3x, negative 4 on both sides. So that will give us 5x squared minus 21x minus 54 equals 0. Okay, so they ask us to use factoring. We will factor. So I'm gonna go, luckily 5 is a prime number, so 5x and x, and I need to think of the multiples of 54 9 and 6 comes to mind. So let me see if I can put 9 here, 6 there. So when I multiply these two, I got 5x squared. That's fine. When I multiply these two, I need to have negative 54. So one of them will be negative. If I put the negative here, so then I will try negative 30x plus 9, negative 21. So that's a correct match. Then I can write it as 5x plus 9 times x minus 6 equals 0. So one of them will be negative 9 over 5. The other one will be 6. Okay, so these are the solutions. All right, so there's another one. This is not a trinomial like the previous one. So this was trinomial, 3 terms, 1, 2, 3. It's already equal to 0. So we don't need to make any of this operation like the red line here. We're going to think something else with the factoring. So we can think of what is the greatest common factor that we can divide those two terms at the same time. That's 5x. And that will be 7x plus 10. That is equal to 0. So then 0 product rule. From here we got 1 root equal to 0. From here we got 7x plus 10 equal to 0. And that will be negative 10 over 7. So that's another one. I'm not going to do the next one because it is very similar to number 3, but I will post the solution key so you can get to that and look at it. Let's see. Other thing was on 1.5 was solving radical equations. Now, the technique in the radical equations is leave the radical term alone, isolate the radical term. Right, so I'm going to add x on both sides, so I will rewrite it here. Let's squeeze it in. Square root of 2x minus 5 will be equal to negative plus 4x. Now I can square both sides. So here I will have 2x minus 5. That was the purpose of it. So radical term should be alone. Then I take square both sides, so then I can get rid of that square root. Now be careful when you're taking the square of a binomial, you need to have a trinomial. So there is a binomial operation. If you take a square of a binomial term, it will be a squared plus 2ab plus b squared. If you have a minus term, the middle term will be minus. So square of the first one, multiply first and second, double it, square of the second one. So you gotta know that for somehow. Or you can open that up, but that will cost you time. Just keep that in mind. So then square of the first term, that will be 16. Multiply first and second, double it, square of the second term. Now I'm solving a quadratic equation, right? So I'm going to make that 2x plus 5 here, so negative 2x plus 5 there. So then this side will be 0, right? Then here I will write first the highest term, x squared minus 10x plus 21. Now I need to use some quadratic factoring techniques, if possible. Then x squared minus 10x plus 21 equals 0. That will give me x minus 7 times x minus 3. That's equal 0. So one root will be 7, the other root will be 3. Now, because we solve a rational inequality, a rational radical equation, we cannot say that both of them will be true. We have to test it. This is the other thing about radical equations. because when we're squaring it here, we had the assumption if two numbers are equal in terms of square roots, their squares will be equal. Well, square root of 4 could be 2 or negative 2. So we wanted to check it. So for instance, I'm going to check for 3 first. So test for 3, it means that negative 3, everywhere I see x here in this equation, I'm putting 3. So negative x, that means negative 3 plus square root of 2 times negative 3 minus 5. Is it equal to negative 4? Let's see. So that is negative 6. That will be negative 11. So that will drop down. So this is not going to check. So let's test for x equals 7. That will be negative 7 plus 2 times 7 minus 5 square root. Is it equal to negative 4? Okay, so that is 14 minus 5, 9, square root of 9, 3. Negative 7 plus 3 is equal to negative 4. Check. So then go back here and write the only solution. Okay, that's done. Let's see. Let me solve. So this is very similar. Look at the solution of the cube root. We don't ask it on the test, but we want you to know for the future concepts. So let me solve one radical equation. I'm on the 12-minute mark and the recording can go only 15 minutes. Then I will save another 15-minute video. All right, so solving rational equations. First of all, let's rewrite this equation. 1 over x is equal to 1 over x plus 3. I've done factoring here, plus x plus 2 divided by x. Greatest common factor is x times x plus 3. So I need to multiply this with x plus 3. I need to multiply this with x plus 3. So I can write 1 times x plus 3, there is x plus 3, equal 1 plus x plus 3 times x plus 2, and everybody has the same denominator on both sides. Okay, once I see the denominator, I need to write the restriction. X cannot be 0, x cannot be negative 3. Now I'm going to deal with only the top part of the equation, because if two rational terms are equal, their denominators are equal, their numerators should be equal. So I'm going to think that x plus 3 is equal to 1 plus, I'm going to open that up, right? That will be x squared plus 5x plus 6. Now I'm solving a quadratic equation here. So negative x, negative 3, negative 3, negative x. Then this will become x squared plus 4x plus 4, right? And then that is equal to 0. So this is actually a complete square of x plus 2, that is equal to 0. So then x plus 2 equal to 0, zero product rule, then that will be negative 2. I go back and see, is there anything that I found here violates this? No. So yes, then I can say that that is the root. Okay, so this was part 1. Hold on for part 2.